Hi all, and welcome to the second video on this part of electricity where we'll be looking at potential difference and resistance. So jumping straight into it, the first thing we're going to look at is resistance. Resistance, as you can see, it's a property of materials, so it's something that every material has in them. So what it does is it slows down the movement of electrons. So every material, even metals, will have resistance. They have something there that will slow down those electrons. Now conductors, like the metals, have less resistance, whereas insulators have more. So again, that doesn't mean that insulators won't conduct, it just means they don't conduct as much, or as easily, I should say. The unit is the ohms, so we measure resistance in ohms, and as you can see, this one's nice and easy, at least with the symbols. The symbol for resistance is R, and what I should say there is the symbol for ohms is omega, or it's this like horseshoe shape. I forgot to put that in, but what I will do is I'll include it on the recap slide next. So why resistance? What causes resistance? So the first thing is that we've got my solid again drawn here, so my metal ions and my electrons, and remember these electrons are free to move. So if I place a potential difference, or I stick this into a circuit with a battery, I can cause these electrons to move in whatever direction I want. But these electrons don't have eyes. They can't sense where these ions are, so as they're moving they will naturally bump into those ions. They'll collide with those ions, and when they do that they'll slow down, and that's what resistance is. So it's caused when these electrons collide with these ions and they slow down. Remember, resistance is when the current gets slowed down. So that's what happens. Now in terms of energy, when you get any sort of collision, the kinetic energy of the particles is turned into thermal energy. So these electrons are moving, therefore they've got kinetic energy, and when they collide with the ions they turn that kinetic energy into heat. So anything that's got resistance will have some heat energy being transferred. You could also say anything with a current will have some heat transferred, because anything with a current will have resistance, and anything with resistance will get hot. So that's why we're told with our electrical cables you shouldn't coil them up when you've got a current going through them, because it can get really hot and actually start fires. Moving on from resistance, this phrase that I keep on mentioning, potential difference. Now the symbol for potential difference is V, because volts, and that's the word that you're probably most familiar with, voltage. So the actual phrase, the GCSE phrase that you should be trying to use is potential difference, but if you can't remember that, it's the voltage. Now what is potential difference? Essentially it's the energy transferred to or by the electrons. So as the electrons are moving around a circuit, they collect electrical energy from the battery, you could say, and they transfer that electrical energy to the appliances. If you give the electrons more energy, they'll move faster. So if you give them a higher potential difference, you'll have a higher current. The units are the volts, and we measure it using a voltmeter. So an ammeter for current, voltmeter for voltage. And whereas you place an ammeter in series within the circuit, we place a voltmeter in parallel. And again, I'll show you a clip on the FET website just to show you how we sort that out. So that's potential difference. It's the energy transferred by the electrons. Now Ohm's law relates resistance and potential difference. Now you don't have to remember this as being called Ohm's law. Yeah, they might mention ohms, but just try and keep in mind that Ohm's law has got something to do with resistance. Now the actual law is that for a fixed resistance, increasing the potential difference gives a proportional increase in current. In other words, if the resistance doesn't change, if you increase the voltage, the current will get faster, which is just what I said here. Remember, if you increase the potential difference, you give the electrons more energy. If they have more energy, they'll move faster. This is the formula we do need to remember though. It's R equals V over I. And again, if you need time to write that down, pause the video now. So the last part of this video, I'm not going to go into a huge amount of detail, because later on when we're doing talking about the the resistance of different components. We'll go through this, but this is how you would set up a circuit to investigate the resistance of a piece of an appliance or a component. Sorry, we've got the power pack here. It could be a battery. You've got your ammeter, a lead connecting the power pack to the ammeter. You've then got another lead connecting the ammeter to whichever the appliances you're wanting to test. So it could be a fixed resistor, it could be a diode, a light bulb. That would go there, and then you would have another wire going into a variable resistor, and from there back to the power pack. A variable resistor is a bit like a dimmer switch in your house. You can change the resistance of that circuit using the variable resistor. And this is what I meant when I said about the voltmeter being placed in parallel. The voltmeter measures the difference in energy before and after a component, and it gives you a reading. So obviously if that component is using more energy, there'll be a bigger difference between those 2 points, and so you'll have a higher voltage or a higher potential difference. If I wanted to measure the voltage of the power pack, I'd do the same thing. I'd put 2 leads in either side of the power pack and have my voltmeter there. Again, the voltmeter would measure the energy of the electrons before the power pack and after, and it would be able to tell me how much energy the power pack is given to the circuit.